I'm going to show you how to take the derivative of arctangent of x using implicit differentiation. So here we've got our equation y equals arctangent of x. Taking the tangent of both sides, that's going to tell me that tangent of y equals tangent of arctangent of x. That's just x. So what I'm going to do is actually differentiate this equation with respect to x, because if I want to find the derivative of arctangent, then what I'm looking for is y prime, or another way to write that is dy dx, if you like Leibniz notation. So what I'm going to do is I'm going to differentiate both sides of the equation with respect to x, and then try to solve for y prime. And so let's go ahead and do that. Differentiating a tangent of y, this is a composition of two functions. My outside function of tangent, my inside function is y. The derivative of tangent is secant squared. Plug in the inside function, and then multiply by the derivative of the inside function. That's y prime. That's what we're trying to figure out. We don't know what that is yet, but nevertheless, we're just going to leave it there. It's equal to something. And the derivative of x, of course, that's just equal to 1. And so this immediately gives us that y prime has to be 1 over secant squared of y. And how do you figure out this? Well, this is a true and correct equation. I mean, this is the derivative of y. But the problem is you want a formula for the derivative in terms of x, not just y. And in a previous video, I've explained how to do this very carefully, but for now, I'll just re-sketch out the argument super quickly. What you want to do is you want to try to draw a picture of the equation that relates y and x together, tangent of y equals x. Go ahead and draw your right triangle. Go ahead and look at your angle y. And if I set the adjacent side here, or the opposite side to x, and adjacent side to 1, then tangent of y is going to be equal to x. And then this length by the Pythagorean theorem will be square root of 1 plus x squared. So 1 over secant squared, that's going to be cosine squared of y. So you just need to take cosine of y, which is going to be adjacent over hypotenuse, and then square it to give you 1 over 1 plus x squared. And that's the derivative of arctangent using implicit differentiation. It's a super quick argument. It automatically gives you the same geometric argument we saw earlier about flipping the tangent line and therefore looking at the reciprocal of the slope. Because, but you can see it in the algebra here, because when you start with y equals arctangent and then switch to tangent y equals x, when you take that derivative, you need to bring that to the other side to solve for y prime, so you see that you get the reciprocal.